This is from higher derivatives, and this is example number 5. Looks like we have to do 3 derivatives, and we're going to start off with our quotient rule. Our top function is x plus 1, so that derivative is going to be 1. Our bottom function is x minus 1, so that derivative is also going to be 1. So when we go to plug things into our quotient rule, it's going to actually be a fairly nice function to work with. So if we say we've got y prime, so we'll start off with dy dx equals f prime is 1 times g is x minus 1 minus f, which is x plus 1 times g prime, which is also 1, and all over x minus 1 squared. So let's clean this up before we move into a second derivative. So our slope dy dx, I have x minus 1 minus x minus 1 all over x minus 1 squared. So this derivative ends up being negative 2 over x minus 1 squared. If you look at this first of all, you might be thinking that to take my second derivative, I should use the quotient rule again. But you don't want to use the quotient rule to take this because your top function is a constant. And if you start looking at the quotient rule, if you take the derivative of a constant, it's actually going to give you a derivative of 0. So there's no real need to use the quotient rule. What we want to do instead is start off with our first derivative equaling something that's more like a power rule, more like the chain rule. And let's go x minus 1 to the negative 2. We could use the quotient rule again, but the derivative of negative 2 is 0, so that whole first part of the quotient rule goes away. And we're going to end up with something that's very similar to what we have here. So that's a hint for you. If you have a rational expression, but the top term is a constant, write it as a chain rule. So now my second derivative, I'm going to change my notation this time to y double prime. My second derivative is going to be the chain rule. So I have a negative 2 to begin with. My exponent that comes down as a negative 2. My original function is x minus 1 goes down a degree to negative 3. And I'm going to times that by the derivative of x minus 1. So way quicker, way cleaner than doing the quotient rule. If I clean this up just a little bit, my second derivative is going to be negative 2 times negative 2, so it's positive 4, x minus 1 to the negative 3, and times by 1. So my second derivative is 4 times x minus 1 to the negative 3. Again, I could write this. If I wanted to stop here, I would say my second derivative is 4 over x minus 1 cubed. That's a great second derivative. But I'm not supposed to stop at a second derivative. I'm supposed to go as far as a third derivative. So my notation for a third derivative is 3 ticks. Still working with the chain rule, I'm going to have 4 times negative 3, and you can go straight to negative 12 with that. X minus 1 goes down a degree, so it goes to negative 4 times by the derivative of x minus 1. So my third derivative, 3 ticks, negative 12, x minus 1 to negative 4 times by 1. So let's clean this up because this is where I do want to end at. I want to have my final answer. My third derivative is negative 12, and the 12 doesn't move to the denominator because it has a positive 1 exponent. The number is negative 12, and x minus 1 to the 4th.